Hi, welcome to our calculus class. And for this class, we're going to start with limits and continuity, chapter 1 of calculus 1. Now, before we go into calculus 1, briefly, we would like to just define what a calculus is and just talk about it for a little while, right? Now, the word calculus is defined as, in general, a rate of change. How one variable is changing with respect to another variable, or how one variable is changing with respect to several other variables. So that's just calculus. Is about change, relative rate of change. Now, so calculus is important in lots of fields of studies, in electrical engineering, in civil engineering, in fact, in all of the engineering courses, in the sciences, in some business courses that you will see as we go on. So it plays a pivotal role, in achieving your goal in those areas. Now, calculus was developed by lots of mathematicians, but the credits were given to both Gottfried Leibniz and Sir Isaac Newton as the two fathers of calculus. So Gottfried Leibniz actually started, and then Sir Isaac Newton joined Gottfried Leibniz because Sir Isaac Newton caught some difficulties when it comes to physics. Sir Isaac Newton was actually into physics, but at a certain stage in physics you need calculus. So Sir Isaac Newton had to commit more time in developing those basic formulas and everything to aid him in the process of physics. Now, calculus is divided into two main branches. So the first branch is the differential calculus, and the second branch is the integral calculus. Now, the differential calculus and the integral calculus is just like the way we have the multiplication and the division. So they are inverses of each other. Now, if you are dealing with differential calculus, it means that you are like cutting something into pieces and seeing as to how you find how they changes, right? Integral calculus is the process of joining smaller pieces, right? So you see differential calculus, you cut something into smaller pieces and observe their changes. And integral calculus, you join those smaller pieces and observe how much you have those smaller pieces. So that's the difference between the differential calculus and the integral calculus. So you will understand as we go on that when we have a particular function to differentiate, when that function is differentiated, and then when we get the derivative of the function, and then if that particular function that we've differentiated, the derivative now, if you integrate the derivative, you are going to undo the entire thing to go back to the function, the original function. So that's what makes the two of them to be inverses of each other. So now we want to take more time now to dive into calculus 1 to see how best we understand calculus 1. So to begin, we want to start with the limits. So the limit describes the value that a function approaches as that same function inputs get closer and closer to some number. Now we say if the value of a function is L and x approaches some value A, then we can write it as the limit of the function f of x as x approaches A equals some L. So the above notation is read as the limit of the function f of x as x approaches some a is equals to L. Now, whenever a particular thing is approaching another thing, it means that that thing has gotten very close to the other. That is to say, if you have the limit, for example, x plus 5, as x approaches 2. Now, when x is approaching 2, it means that x is very, very close to 2. For example, if you have, this will be our 2, and on this side is 1, remember. This side is 3. When a value called x, when a value called x is approaching this 2, it means it's either approaching this 2 from the left, which could probably be 1.99, 1.9999. It will also be 1.99999, and so on, right? It means that it is very, very close to this 2. When it is approaching this 2 from this side, which is the right, it could probably be 2.001, 2.0001, 2.00001. So it means that if it is approaching 2 from the right, it is very, very close to 2. When it is approaching 2 from the left, it is also very close to 2. So because you just have values that are almost like 2, meaning this 1.9999, if you round it up, is equals to 2. This 2.001 is also 2, right? So because we may not want to have much problem with dealing with these decimal numbers, so for now, we are going to use the value that x is approaching. So when x is approaching 2, we just want to replace the variable with